ఇది వరకు టైం పడుతుంది. బంద్ చేసేసారు. ఇది బంద్ చేసేసారు. Good evening, students. So yesterday we have completed block 1. So today we are starting block 2. It is a multiple integrals. Block 2 is multiple integrals. So in that unit 4 is, so we are starting unit 4. Unit 4 is the transformations. In that, transforming one polar coordinates into another polar coordinates. So that is spherical coordinate is there, cylindrical polar coordinates are there. So like the different coordinates are there, you have the definitions in your textbook, so you can refer them. So first if you see what are the polar coordinates. Okay. So the polar coordinates means here, we know we have seen the co-initial vectors. So same like that only here. So like this, it has only the point O as a origin. So here it makes the angle theta. This we know that it is called as initial ray. Okay, this is the point here. We call that point as P. So the distance from O to P is R. Okay, this is, we call it as a pole. O to P is called as a pole. And here whatever O is there, that is the origin. Okay. So this P, whatever it is there, it has the coordinates as P, R, comma, theta. Okay. So this whatever P, R, comma, theta is there, that is called as a polar coordinates. And here R is the distance from O to P. R is small r is the distance from O to P, and it is making the angle theta. So with the help of this theta, we can find what is cos theta, what is sin theta, and also what is tan theta. Okay. So if P has Cartesian coordinates, x comma y, then relation between them is, that is x is equals to r cos theta and y is equals to r sin theta. Okay. So when you do for these two, squaring on both sides and adding them, you get it as x square plus y square is equals to r square into cos square theta plus sin square theta. Where cos square theta plus sin square theta is 1, so you will get it as r square. Okay. So x square plus y square is equals to r square implies r is equals to root of x square plus y square. Okay. So like this, with the help of that is polar coordinates is p of r comma theta. So how you will get r value and how you will get theta value. So r value you will get from this one root of x square plus y square, and theta value you will get from here x by r is equals to, that is theta is equals to cos inverse of x by r, and here theta is equals to sine inverse of y by r. Okay, that is cos theta equals to x by r, sine theta equals to y by r, and we know that tan theta is sine by cos. So tan theta equals to y by x. Okay. So like this, we have to find the values in the problem, and you should know the concept of what are the polar coordinates. So the 5 marks question you will get for conversion of any given coordinates into Cartesian coordinates, or converting the polar coordinates into Cartesian coordinates. So here Cartesian coordinates are x comma y, polar coordinates are r comma theta. So from here to, that is Cartesian to polar, or from polar to Cartesian, that will be mentioned in the question. So with the help of that, you need to find the problem. So convert minus 4 comma. So one problem we are seeing, convert minus 4 comma 2 pi by 3. Okay, into Cartesian coordinates. Into Cartesian coordinates. That means here in the given question, whatever the coordinates are there, those coordinates are polar coordinates. That is, r value is minus 4 and theta value is 2 pi by 3. So we need to find the value of x and y. So in the given question, whatever the values are there, you write that one. Given r is equals to minus 4, theta is equals to 2 pi by 3. Okay. So the relation between polar coordinates and Cartesian coordinates, just now we have seen the relation between Cartesian and polar coordinates is this one, x equals to r cos theta, y is equals to r sin theta. So here we know x value and theta value. If you substitute here, you will get x and y values. Okay. The relation between polar and Cartesian coordinates is x equals to r cos theta, y is equals to r sin theta. Okay. Now substitute the values here. That is, x is equals to, what is r is minus 4, cos theta value is 2 pi by 3. And here y is equals to r is minus 4, sin 2 pi by 3. Okay. So 2 pi by 3 means 2 into 180 by 3. That is 3, 6 are 18. So it is 120 degrees. So x equals to minus 4 cos 120 degrees. And here y is equals to minus 4 sin 120 degrees. Okay. Only he has asked you to find the Cartesian coordinates. No? You can keep like that only. If you want to find the what is x value and what is the y value, you can convert them into 120 degrees means 90 plus 30 degrees. And here sine also 90 plus 30 degrees. You can convert like this. x equals to minus 4 cos 90 plus 30 degrees and y is equals to minus 4 sin 90 plus 30 degrees. So cos 90 plus theta, cos 90 plus theta is minus value you will get, that is it will become sine, cos will become sine and minus of minus is plus. So 4 cos that sine 30 degrees and y is here minus 4 sin 90 plus theta. Sin 90 plus theta is positive value. So minus 4 sin will become cos. That is cos 30 degrees. So sin 30 is 1 by 2. So x equals to 4 into 1 by 2 and y is equals to minus 4 into root 3 by 2. So 2 times, here 2 times. So x equals to 2 and y is equals to minus 2 root 3. Okay. So like this we can find the value of the x and y. X and y are here Cartesian coordinates. So here you can write therefore Cartesian coordinates x comma y is equals to 2 comma minus 2. Okay. So like this we have to find the value of the given whatever the concept is given in the problem, you can find like this. So first you should know the relation between polar and Cartesian coordinates. When you know the relation, try to substitute the whatever the given values are there in the problem, then you convert them. So you will get here the Cartesian coordinates. If in the question polar coordinates are given, that means here polar coordinates are given. If in the problem Cartesian coordinates are given, that is x and y value are given, then we need to find r and theta. Okay. So such type of problems will be also there. So one more problem is there in which convert y square equals to 4x into polar form. Okay, polar form means we need to find r comma theta. So both the problems will be there. One means converting into Cartesian coordinates, another one is converting into polar coordinates. So convert y square equals to 4x into polar form. Polar form means we need x and that is r and theta values. So for this one, put x equals to r given, you can write first given y square equals to 4x. You take it as equation 1. Okay. Put x equals to r cos theta and y is equals to r sin theta in 1. Okay. So when you substitute here, what you get? R sin theta whole square is equals to 4 into r cos theta. So when you do the square of this one, it is r square sin square theta equals to 4 r cos theta. 1 r will get cancelled. So you will get 4 cos theta equals to 4 cos theta equals to r sin square theta. So we can write it as, so 4 is equals to r into sine square. We can write sine theta into sine theta by cos theta. Okay. So it is equals to r into sine by cos means you will get tan theta into sine theta. Okay. So 4 is equals to r into tan theta into cos theta. So what is r value? That is r is equals to 4 by tan theta into sin theta. Okay. So r is equals to 4 into 1 by tan theta means what? Cot theta. And 1 by sin theta means cosecant theta. So r value is 4 into cot theta into cosecant theta. Okay. So we are converting this into polar form. So polar form is r is equals to 4 into cot theta cosecant theta. Okay. So whenever such type of question is asked, we have to follow this procedure. So first thing, in the given equation, whatever the equation is there, in that equation you substitute x equals to r cos theta and y is equals to r sin theta. So when you do the simplification, you will get the r value here. Okay. Next we have spherical polar coordinates. So spherical polar coordinates, whatever the definition is there that you have in your textbook. So the spherical polar coordinates, this is the three-dimensional coordinate system. Before one, we have seen only x and y were there. That is two-dimensional coordinate system was there. The spherical polar coordinates are the three-dimensional coordinate system. So you will have x-axis, y-axis, and also z-axis. Okay. So the coordinates of a point P are given by ordered triad. So for this one, spherical polar coordinates, you will have the triad as that is P comma theta comma pi. So where whatever this P is there, that we can call it as a rho. Okay, rho equals to the distance from origin to P, where rho is greater than or equals to 0. And theta equals to same as in polar coordinates. Theta is the angle. Okay. Pi is the angle between positive z-axis and a line from origin to P. Okay. So these all, whatever the definitions are there for rho and theta and pi, you have in your textbook. You can see from there. Spherical polar coordinates. So this will be like this: rho, theta, and pi. Okay. So diagram, it is a three-dimensional now. So three-dimensional means you will have, this is x-axis, this is y-axis, and this is z-axis. Here, whatever it is there, it is making theta. This is r here, and here whatever it is making angle, it is pi, and this is rho, and this is the point P. Okay. So point P is having a x comma y comma z. Okay. So the relation between Cartesian and spherical coordinates. Relation between, so these relations are important for solving the problems. Relation between Cartesian and spherical coordinates is z is equals to rho into cos pi and r is equals to rho into sin pi. and z square plus r square equals to rho square. Okay. So z is equals to rho into cos theta, r is equals to rho into sin phi. So when you do the square on this, z square plus r square equals to what is there? Rho square will be there. Okay. So we know already Cartesian coordinates are x equals to r cos theta, y is equals to r sin theta. And we know the relation r square is equals to x square plus y square. So x is equals to here in place of r, that is cos theta is there. So when you substitute here, you will get x equals to rho sin pi cos theta. Okay. So what is r? R is equals to rho into sin pi. So you are substituting here rho into sin pi. And if you substitute in y is equals to r, y is equal to r sin theta, r is rho sin pi sin theta. Okay. And what is z? Z is equals to rho into cos pi. And here, what is rho square? Rho square is equals to x square plus y square plus z square. Okay. So rho square is equals to already z square is there. What is r square? R square is x square plus y square. So when you substitute here, you will get it as x square plus y square plus z square. Okay. So from this diagram, you have the here polar coordinates as rho comma theta comma phi. Here it is making the angle phi and here it is making the angle theta. Okay. So the relation between Cartesian and spherical coordinates. These are the spherical coordinates and Cartesian are x comma y comma z. So from here z is equals to rho into cos phi, r is equals to rho into sin phi. So when you do the square of both of them, you will get as this relation. And we know already what is Cartesian relation. When you substitute this x and y, in x and y, r value, you will get x equals to this one, y equals to this one, z equals to this, and rho square equals to this one. So with the help of these all relation, these are useful for solving the problem. Okay. So the question will be convert the point 4 comma pi by 4 comma pi by 6. Means here polar coordinates are given, that is rho value is given, theta value is given, pi value is given. So convert the point from spherical to rectangular coordinates. Okay. So yes, spherical polar coordinates are given in the question. We need to convert them into regular coordinates, rectangular coordinates. So rectangular coordinates are nothing but x comma y comma z. Convert the point pi by 4 comma pi by 6 from spherical to rectangular coordinates. Okay. Solution is given. So it is rho is equals to 4, theta equals to pi by 4, and pi is equals to pi by 6. Okay. So we know that x equals to, what is x? X is equals to rho into sin pi cos theta. So x equals to, what is rho value? Rho value is 4. Sin, what is pi? Pi is pi by 6. And cos theta is pi by 4. So x equals to 4 into sin pi by 6 means 30 degrees, and cos pi by 4 means 45 degrees. So x equals to 4, sin 30 is 1 by 2, and cos 45 is 1 by root 2. So x equals to 2 by root 2 will get. So 2 we can write it as root 2 into by root 2. So root 2 gets cancelled. So it is root 2. So x value is root 2 here. We need to find the y value and also z value. So here y is equals to, what is y? Y is rho sin pi sin theta. So rho is 5, 4 sin pi is pi by 6, and sin pi by 4. So it is equals to 4. It is sin 30 degrees. Sin 30 degrees and sin 45. So it is equals to 4 sin 30 is 1 by 2 into sin 45 is 1 by root 2. Same you will get. It is root 2. Okay. So here y value is also same. Now what is z value? Z is equals to rho into cos pi. So rho is 4, and what is pi? Pi is pi by 6. It is 4 cos 30 degrees. So cos 30 is root 3 by 2. So cos 30 is root 3 by 2. That is 4 into. So z is equals to 2 root 3. Okay. So that is not visible here. Okay. So it is equals to 4 into root 3 by 2 is equals to 2 root 3. Okay. So z is equals to 2 root 3. So the rectangular coordinates are, therefore rectangular coordinates are x comma y comma z is equals to, so the values are root 2 comma 2 root 3. Okay. So root 2 2 root 3 are the rectangular coordinates of the given spherical polar coordinates. So this is the, if you know these relations of x, y and z, then you can do the simplification. Okay. So compulsory, the relation should be remembered for solving the problems. So here x equals to rho into sin pi into cos theta, y is equals to rho into sin pi into sin theta, and z equals to rho into cos pi. So with the help of these three relations, we can convert the point from spherical to rectangular. So in some case, a rectangular will be given. We have to write the spherical polar coordinates also. Next, another coordinates are the cylindrical polar coordinates. So cylindrical polar coordinates, for each and every polar coordinates, you have the, that is a representation is there with the help of the diagram. Cylindrical polar coordinates means cylindrical So cylindrical polar coordinates means with there is three-dimensional will be there. This is y, x, y, and this is z we have. R, this is theta here, and this whatever it is there, r comma theta comma. R comma theta comma z. Okay, this is the diagram, diagrammatic representation of the cylindrical polar coordinates. A point P. So this is the point P here. A point P. R comma theta comma, that is a point P in space is represented by ordered pair triple, that is r comma theta comma z. R and theta are polar coordinates here of projection of P on the xy plane. On the xy plane they are projecting here. So and z is directed distance, and z is the directed distance from the xy plane to P. So to convert cylindrical coordinates to rectangular coordinates, we use the relation to convert cylindrical coordinates to rectangular coordinates. We use the relation, that is x equals to r cos theta, y is equals to r sin theta, and here z is equals to z. Okay. So with the help of these three relations, we can find the value here. So from rectangular to cylindrical, coordinates, r is equals to, x square plus y square, and tan theta is equals to y by x, and here z is equals to z. Okay. So these relation and these relations are useful for solving the problems. Whenever any point is given, he is asked to convert into cylindrical coordinates, or cylindrical coordinates are converted into rectangular coordinates. Okay. So we have one problem. I'm converting the point into cylindrical coordinates. Convert the point So convert the point 1 by 2, comma root 3 by 2, comma 5 to cylindrical coordinates. So solution, point mean it is given x, y and z values are given here. So since x equals to 1 by 2, y is equals to root 3 by 2 and z is equals to 5. Okay. So we know the relation x equals to r cos theta. So and we know one more relation, that is r is equals to root of x square plus y square. So that is r is equals to What is x? 1 by 2 whole square plus what is y? Root 3 by 2 whole square. So it is equals to root of 1 by 4 plus 3 by 4. So it is 4 by 4 means 1. So you will get r value as 1 here. Okay. And we have one more relation, that is tan theta equals to y by x. So what is y value? Root 3 by 2 and x is 1 by 2. That is, if we take the reverse, 2 by 1, 2 will get cancelled. It is root 3. Okay. So tan theta equals to root 3 implies theta equals to tan inverse root 3. Okay. So for tan 60 degrees, we'll get the value of root 3. So theta is equals to tan inverse of tan 60 degrees means pi by 3. So tan and tan inverse both will get cancelled. So it is pi by 3. So theta value is pi by 3. And what is z here? Z in the given question is pi. Okay. So for rectangular coordinates to converting into cylindrical coordinates, first thing is the relation is tan theta equals to y by x. And second relation is r is equals to x. We need to find r value, no? So r is equals to root of x square plus y square. Okay. And we know already z equals to pi. So what are the cylindrical coordinates? Cylindrical coordinates are r, theta and z. So therefore, thus the given point in cylindrical coordinates is r comma theta comma z. Okay. Cylindrical coordinates is r comma theta comma z. So what is r value? R value is 1. Theta value is pi by 3. And z value is 5. Okay. So like this, we have to solve the problem. Whenever a point is given and it is asked to convert into cylindrical coordinates. So in the definition of the cylindrical coordinates, I have told the relations. So if you remember those relations, that is r is equals to root of x square plus y square and tan theta equals to y by x to get the theta value. And we know already z will be given in the question. So from the given problem, take the values of x, y and z. So if you take those values, we need r value. So this x, we no need of this one. From here, first thing is we need r. Then we can find the theta value from here also. Okay. So r is equals to root of x square plus y square. X is given, y is given. When you substitute here, you will get r value as 1. So we know tan theta. Tan theta is y by x. So y by x are given in the question. Substitute those values. So you get tan theta equals to root 3. So for what value of tan, you will get the angle. For what value of theta, you will get the value as root 3 means tan 60 degrees is root 3. So in place of root 3, substitute tan pi by 3. So tan and tan inverse both will get cancelled. So theta will be pi by 3. And from here given point, z value is 5. So the given point in cylindrical coordinates is r comma theta comma z. So r is 1, theta we know, theta is pi by 3 and z value is 5. Okay. So this is the conversion of given point into cylindrical coordinates. So in unit 2 only, so many example and exercise problems are there. So on these 3 transformations, polar, spherical and cylindrical. Okay. So in unit 4, only one last topic is there, that is the Jacobians is there. So Jacobians is nothing but two whatever the functions are given. That is, if u and v are the functions of two independent variables x and y, then determinant of dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y is called Jacobian of u and v with respect to x and y. How it is represented? It is given. So with respect of two independent variables, it is there, and with respect of three independent variables also, it is there. Okay. So when in the given question, three independent variables are given, then you have to do this. You have to follow the second formula. If only B are there means, then you can use the another one. Okay. Or Jacobins. So Jacobians means if u comma v are and v are functions of two independent variables of two independent variables x and y, then dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y is called the Jacobian of u and v with respect to of x and y. Okay, so it is denoted by dou of u comma v by dou of x comma y, or even denote it as j of u comma v. Okay, this is called the Jacobian. So with respect to of two independent variables will be there, and also with respect to of three independent variables also it will be there. For three independent variables, dou u by dou x, dou u by dou y, dou u by dou z. Next, dou v by dou x, dou v by dou y, dou v by dou z, dou w by dou x, dou w by dou y, dou w by dou z. Okay, so is called Jacobian of u comma v comma w with respect to of x comma y comma z. Okay, x comma y comma z, and we denote it as u comma v comma w by dou of x comma y comma z, or j of u comma v comma w. Okay, so like this. So definition is there for Jacobians. So here, if u and v are the functions of two independent variables x and y, then Jacobian of u and v with respect to x and y is given as dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y, and we denote it by dou of u comma v, dou of x comma y, or j of u comma v. J here means, if you see the j means it is Jacobians. So if three variables are there, and here functions are u, V and W. Three functions are there. So like this, the representation will be there. So problem will be both on two variables and also three variables. It will be asked in the examinations. Okay. So if two variables are given, so how to find? Just we'll see one example problem. If u is equals to e to the power of x sine y and b is equals to e to the power of x cos y, then find dou u comma v by dou x comma y. Okay. So here u and v values are given. We know that dou u comma v by dou x comma y is equals to dou u by dou x, dou u by dou y, dou v by dou x, dou v by. Okay, we know this formula. Now substitute the values here. So it is equals to dou u by dou x. So what is the u value here? So you can write this one separated as dou by dou x into like this also you can write, or directly you can do the partial differentiation also. Okay. Dou by dou y of what is u? U is e to the power of x sin y. Next dou by dou x, what is v? V is e power x cos y. Next dou by dou x, dou by dou y, v is e to the power of x cos y. Okay. So this partial differentiation of e power x here, why it is there means it is constant. So e power x is e power x only, and sin y you have to write like that only. Here with respect to of y, e power x is constant, so keep like this only. Sin y differentiation is cos y. Okay. Next here with respect to of x means e power x is e power x only, cos y like that only. With respect to of y means e to the power of x cos y is minus sin y, minus e to the power of x sin y. Okay. So now when you find the determinant of this one, it is a 2 by 2 matrix. 2 by 2 determinant, it is the no, just if we do the cross multiplication, it's enough. So minus e to the power of x into e to the power of x minus e to the power of x whole square sin square y minus e to the power of x whole square cos square y. Okay. So here if we take out minus common, e to the power of x whole square common if we take out, it is sin square y plus cos square y. So it is minus e to the power of x square. This value we know it is 1. So it is equals to minus e to the power of x whole square. So this is the answer for this Jacobian with respect to of the two independent variables. So by this we are completing unit 4 from the block 2. Next we have unit 5 is there. Unit 5 is double integrals, change of order of integration. So we know already the concept of the definite integral. Definite integral is nothing but that is a to b f of x dx is physically the area under a curve y is equals to f of x. The x-axis and the lines x equals to a and x equals to b. It is defined as a limit of the sum. Okay. So double integral is the counterpart of the above definition in two dimensions. So single differentiation means that is only one time we'll do the integration and we'll substitute whatever the limits are given in the problem. So if double integration is there means two times you have to do the integration and we have to substitute the whatever the limits are given in the problem. Okay. So definitions are there in the textbook in the unit 5 about the what is the double integration with respect to of the variables and x and y. So you can see those definitions. First we know that it is definite integration. So we will write it as a to b f of x dx. It is equals to f of b minus f of x. Okay. So like this, we find the definite integration whenever the limit values are given. That is upper limit and lower limit. If a function is there, after doing the integration, we'll substitute the limit values and we'll find the value. Okay. So whenever the integration of 2, that is double integration is given like that, like this will be there. If R is any limit, function will be f of x comma y dx and dy. Will represent like this as double integration. So it is equals to a to b x1 of y, here x2 of y. F of x comma y into dx into dy like this. Okay. So with respect to of y will be there and also with respect to of x will be there. So here if double integration is given means one whatever the limit values will be there, you take it as a constant outside. And one more, whatever the limit are there for the integration, you do first that one, after that do the second one. Okay. We'll see one problem, then you can understand the concept here. So evaluate x equals to 0 to 2, y is equals to 0 to 3, x, y, dx, dy. So here evaluate x equals to 0 to 2, y equals to 0 to 3, x, y, dx is given. So here x equals to 0 to 2, y is equals to 0 to 3, x, y, dx, dy. Okay. First you take outside the x limits, that is x equals to 0 to 2 and do the integration for y equals to 0 to 3, x, y, that is x, y with respect to of d, with y limits we are doing now. So x, y, dy and dx you take outside. Okay. So it is equals to okay. Okay, first you have to do the differentiation, that is the integration of xy dx. So here, when you are doing the integration of variable y, you keep the x as a constant. So it is equals to x equals to 0 to 2, x you take it as a constant And when you will find the integration for that is integration of y equals to 0 to 3 into dy into dx. So it is x equals to 0 to 2, x is there, y integration is y square by 2 and the limit values are 0 to 3. So dx will be there. So it is x equals to 0 to 2 x into upper limit minus lower limit. So it is 3 square by 2 minus 0. That means you will get 0 only. So dx. So it is x equals to 0 to 2 x into 9 by 2 into dx. So 9 by 2 is the constant value now. So you can take outside 9 by 2 integration of x equals to 0 to 2 x into dx. Okay. So here it is equals to 9 by 2 you take outside x equals to 0 to 2 x into dx. So x integration is 9 by 2 x square by 2. So 0 to 2. Upper same here also upper limit minus lower limit 9 by 2 2 square by 2 minus 0. So 9 by 2 is 4 by 2. So 4 by 2 means 2. That is 9. 2 will get cancelled. So the value is 9 here. So it is equals to 9. Okay. So the value of double integration of x equals to 0 to 2, y equals to 0 to 3, xy into dx into dy is 9. So like this we have to find the double integration for the any given function. So double integration for the Jacobi's is there and also for the some other limits are given. Whenever some other limits are given, how to find the